Okay, here we go. So we're in homework number 3, lecture unit 1, homework 3, converting foreign to base 10. Okay, so what we're doing this morning is we're going to go from foreign numbers to base 10 numbers. So here now our first example, 3,556. What am I going to do with 3,556? What they're asking me to do is write the following number in expanded form. What do they mean, expanded form? Well, they want me to take 3,556 and they want me to write it piece by piece. What do we mean? Start with the 3. What does that 3 represent? You guys know it's 3,000, isn't it? Plus, and then what does that 5 in that place represent?
500.
500.
500, exactly, you know. And what does the 5 in the next place represent?
50.
That one's 50, exactly. And then the 6 is just 6. That's all they want you to do on question number 1. Super easy. But the reason they're doing it, the reason I am doing it, I included this question, is because I want you to think clearly about place values. That's what this is all about. That's why we're doing this whole unit, really, is to become more and more clear on what our system really is all about. And so this is an example, just to be super clear, about the place values. The 3 is in a certain place, right? He's in the thousands place, isn't he? And this 5 is in the hundreds place, and this other 5 is in the tens place, and this 6 here is in the ones place. And that you know, right? Those are the place values of those numbers. And so we have a base what system? What is our system? It's a base what system?
Base 10.
Is that already? Yeah, we have a base 10 system. Now, what do we mean we have a base 10 system?
That it goes by tens, or no, that it multiplies by 10.
To get from 1 to 10, you multiply by 10. Yeah, I hope you know the answer to that question better than you did a week ago. And when you teach younger folks, you'll know exactly, especially by the 3 weeks from now, by the time we're done with this unit, I think you will know super well what it means that we have a base 10 system. It means the place values you multiply by 10. You start with the ones place. You always start with the ones place. Remember, it was the same thing even in the Mayan system that we did Monday. We start with the ones and we go times 10 is 10, times 10 is 100, times 10 is 1,000, right? The fact that we have a base 10 system, and then it's etc. It just, if you wanted to do more, it would just keep multiplying by 10, wouldn't it? So we have a base 10 system, which means the place values multiply by 10 every time. Okay, great. Well, to become more clear about that and what that really means, we're going to now do work in other bases. Just like we did the Mayan system Monday, which was base 20, now we're going to do, on this first example, on question number 2, we're going to do a base 2 number. And there it is. I'm going to write it a little bigger. So 1, 1, 0. Like, let me space it out even a little bit more, I think. 1, 1, 0, 1, 0, 1. So there we go. There's our base 2 number. And what I want to do is I want to start with the place value. So right here, we start with the ones. This is the place values. So the place values. So we start with the ones place. And then now, we did the same thing in base 10, right? We started with the ones place. And then how did we find the next is the base 10? We multiplied by 10. So guess what I'm going to do to find the next place value when I'm in base 2?
You're going to multiply by 2?
Exactly. Everybody seen that? This is going to be the 2's place, which seems weird, but that's what it is. That's the same thing we did in base 10, right? We started with the 1 and we multiplied by 10. And then how do we find the next? We multiply by 2 again, right? You just like we kept multiplying by 10 in the base 10 system. So in the base 2 system, we just keep multiplying by 2. So 1 times 2 is 2, times 2 is 4. This must be the 4th place. Times 2 again, this must be the 8th place. Times 2 again, this must be the 16th place. Times 2 again, this must be the 32nd place. That good so far? So we start by finding the place value. We just multiply by 2. Just start with the 1s. They always start with the 1's place. All these systems start with the 1's place. And then you just multiply by the base. In this case, 2. So times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16, and times 2 is 32. All right, now we have one more step. Now to finish off
a base 5 system. The only modern digits we need for base 5 would be 0, 1, 2, 3.
Uh-oh. Let's hold on to the video there.
4, 3, 2, 1, and 5.
Yeah, that's Mr. James Sousa. And if you could mute your video, please.
This becomes
I don't think it's me, is it?
3, 5 system. The only the 5.
No.
Good.
First is 2, 5.
Oh, I'm still
Yeah.
hearing it. Are we all good? All right. You know, that's almost kind of offensive. You know, I mean, you'd prefer to listen to the James Sousa lecture to my lecture. I'm totally kidding. I don't care at all. Do whatever helps you the most. He's a fabulous lecturer. I just thought that was hilarious. All right, let's move on. We had 2 math lectures at once coming over the audio. All right, so now to finish up this problem. I'll quit joking around and get on here. So to finish up this problem, what we need to do, think with me. This is where it's helpful because you're going to teach younger folks our system, right? Think what we do in our system at this point. What do? We multiply, right? We take 3 times 1,000. That's why it's 3,000. Because, oh, here, let me refresh my screen. You didn't see that. There we go. Up here. We take 3 times 1,000. 3 in the thousands place. Well, we do the same thing here in the base 2. We take 1 times 32. You multiply the 1 times the 32. And so what is that going to equal? Let me put it up here. That'll equal 32. Plus, and then you do the next one. 1 times 16. Right? And then the next one. 0 times 8, which is 0. Plus 1 times 4, which is 4. Plus 0, what's 0 times 2? It's just 0, right? 0 times anything is 0. And 1 times 1 is 1, and then you just add them up. Let's see, what, 48, is it 53, I think? And that's our answer, 53. That is a base 10 numeral. Why? I mean, it's just base 10 just means normal. That's like our system, regular. We're done. There it is. There's question number 2. You see how that worked? So again, you just write out the place values. You start at the 1's place, and you go times 2, times 2, times 2, times 2, etc. And then you just multiply what's in that place times the place value. That's exactly what we do in our system. You just know it so well, you don't think about it intentionally. But that's really what we do, right? How do we get 3,000? Well, because it's 3 times 1,000. It's 3 multiplied by his place value. 3 1,000s. That's 3,000. And then we what? We add them up. See how we add them up? That's exactly what we always do in our system. We just know it so well we don't even think about it anymore. Well, this will help us be intentional to think about it because we're doing it in a different base system, in this case, base 2. So you just multiply, 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 and then add them all up, and 53 is our answer. Questions I can answer on that one?
So just to recap, sorry, I kind of joined a little bit late.
Okay, so on to question number 3. So now I'm going to do base 3. So same exact game plan, it's just base 3. And in fact, I think I'm going to move it to a fresh sheet where I got a little bit of room. So let me grab the question. So number 3, my number 3 anyway, says 1, 2, 0, 2, 2, 1. So question 3. Question 3, 1, 2, 0, 2, 2, 1. Got that right? 1, 2, 0, 2, 2, 1. Beautiful. Okay, and that's base 3. It's a base 3 number. Base 3. Okay, so what do we do first off? We gotta write down the place values. So let's do it. So the place values for each of these. And we know that we start with the ones place, right? And then we just keep multiplying by 3 every time, because now we're in the base 3 system. So this is going to be the 3's place. Multiply by 3 again, 9's place. Multiply by 3 again, 27's place. Multiply by 3, 81's place. Multiply by 3, 243's place. Just use your calculator as you need it. 243's place. So there we go. Now, how do we finish off the problem? So we just found the place values. Right down here, these are the place values in the base 3 system. Just like in our base 10 system, we have the 1's place, the 10's place, the 100's place, the 1,000's place. In the base 3 system, they have the 1's place, the 3's place, the 9's place, etc. So now we multiply, don't we? Multiply and add. Multiply and add them up. Right? So I go 1 times 43, because I have 1 in the 243's place. Well, that's just 243. And then 2 in the 81's place. What's that, 162? Right? Because that's what that means, doesn't it? Is that making sense? It's 2 in the 81's place. So 2 81's is 162. And then 0 27's. Well, that's my favorite. That's just 0. That's just easy, right? You have no 27, so that's just 0. And then 2 times 9. 2 in the 9's place is 18. 2 9's is 18. And then 2 times 3, 2 3's is 6. And 1 times 1, 1 1 is 1. Add them up. I'm going to use my calculator. Let's see, 162, 18 plus. Okay, I'm getting 430. Did I do that right? Yeah, that's right. Okay, so that's 430, and we're done. That is a normal, and by normal we mean base 10 number, right? That's our normal system is base 10. So that's our answer. That's a normal base 10 number. There we go. Questions on that one? That's the base 3 example. Okay, so number 4 now. Let's go on. Question 4 is a base 5 number. Same kind of thing. It's just base 5. 2 4 3 1 2 3. 2 4 3 1 2 3. So let me add a page here. And question number 5. 2 4 3 1 2 3. I think. Did I get that right? 2 4 3 1 2 3. Yep, that's my base 5 example. So this is base 5. Okay, so it's the same deal. You begin by writing the place values. So let me put the lines here for the place values. And this is the 1's place. And now what do? We go times 5, right? So you always multiply by the base number. It's exactly what we do in our system. That's how we get 1, 10, 100. You multiply by 10 every time. So in base 5, you multiply by 5 as you jump from place to place. So this will be the 25's place. And then you multiply by 5 again. You know how to multiply by 5. Think about money, right? We deal with money all the time. 5 quarters, 25 times 5 is like, 5 quarters. You know how much 5 quarters is? $1.25, right? So 125. And then you can do it again. Just think about money. What if you have $1.25 5 times? What's 125 times 5? $1.25 5 times. Well, that's $5 and then 5 quarters. And so that's $6.25, isn't it? And then we do it again. If you have $6.25 5 times, well, 5 times $6 is $30 and then 5 quarters. So it's $31.25. We know those numbers pretty well because we deal with money all the time. All right, anyway, there we go. There's the place values. Use your calculator if you prefer. So we find the place values. We just multiply by 5 every time to get the place values. And now, what am I going to do to finish getting to my final answer here? It's my last step.
Multiply the two numbers.
There it is. Yep, we multiply and add them up. Multiply and add them up. So I'm going to go times 2 times 3125. That's going to be 6250. 6250, because that's 2 in the 3125's place. I stopped putting the S's here. There we go. 2 in the 3125's place. So that's 2 times 3125, 6250. 4 in the 625's place. 4 times 625 is at 2, 4, 2500. Let me use my calculator. Whoops. Yeah, 2500. 2500. And then 3 in the 125's place. 375. 1 in the 25's place is 25. 2 in the 5's place is 10. And 3 in the 1's place is just 3. Add them up. Let me see. Using my calculator here. I'm getting 9163. There we go. That's the normal. This is normal base 10 number. There we go. We did it. Questions on that one? Questions I can answer. Okay. So here we go. So to number 5, whoops, put that in there, to number 5 we go. So question number 5 is, I'm just going to make one up, a base, I think there's 4 digits, right? Isn't it a 4-digit? Yeah. But mine came out a little tame. I want to make one a little harder. So how about 3, 10, 11, 8. So this is a base 12 number. Notice that it puts commas between the numbers. So commas between the numbers. And it does that because in base 12, you can actually have a 10 or an 11 that's just in one place. And so to help be clear what the different places are, they separate them with commas. So it's super clear what the different places are. All right, but basically the game remains the same. We just start right here with, we just put in our lines here. We're going to do the different place values. This is the 1's place, like it is in every system, including the Mayan. Every place value system. The Romans didn't have a place value system, right? But the Mayans did. They started with the 1's place. And all these are place value systems. So start with the ones place, and then I'm going to multiply by 12. This is the 12s place. And then multiply by 12 again, because that is our base here. And so this is going to be the 144's place. And then multiply by 12 yet again. I'm using my calculator. This is the 17/28's place. So far, so good. So we just multiply by the base values, right? And that's how we find the place value. So multiply by the base, the 12, and we find the place values. And now to finish up the problem, you know what to do. We multiply and add them up. Multiply and add them up. So I'm going to go times 3 times 17/28. Use my calculator here. $51.84. The next one, 10 times 144. 1440. Next one, 11 times 12. 132. Next one, 8 times 1 is 8. And then add them up. This would be the number, like I got 6,764. There we go. This is the normal base 10 number. And so there it is. There is how you do base 12. Just like that. Questions on that?
So what's the difference between this one and